Now, one of the studies we've done in the past is using radiotelemetry to look at actual dive depths. In the case of this species, which is lesser scaup, this is the actual proportion of bird diving that are found at this depth roughly, relative to the underlying graphic, that's the estuary itself. There's a lot of shallows in the estuary over here, but it's still much more use of those shallows than in proportion to what's out there. So lesser scaup, we see this high use of the shallows, and when we calculate it out, we see like 32 to 40% of the area of the estuary is used by this species. So what we're interested in is whether or not that maybe the current shoal habitats that are preferred by them, and this is something Bruce helped me on, the slides that I'm going to pass over this quickly, is that the change that we expect to happen in the bed levels of places like Sassoon Bay, that as they change to getting deeper, they will change most likely the distribution of migratory bird species like lesser scaup, because then the depth of the elevation of where the birds are typically diving is altered, and they're usually not at preferred depths. Even though it looks like the birds are out just on the open bay foraging, they're out in the bay foraging in optimum depths, or at least preferred depths, for maximizing energy gain. And as soon as those depths get much deeper, these ducks will refuse to keep foraging, they'll move on. And that's one of their big concerns. So can this be a flyway effect? And I can't answer this question, and it's certainly one of the most difficult ones we're going to face in the issue of climate change. But I will point out something, and that's from our recent work on looking at shorebirds marked on the west coast with the cooperative network up the coast and trying to follow their migration. And that is that birds during spring migration stop at each area for just a matter of a couple days. 2 or 3 days is the average stop that a bird might do in a particular wetland up the coast. So all this effort to save these particular wetlands are based on that. They get a lot of food in a short time and can move on to get to the breeding grounds. With the change in moving the climate up, or at least making it where there's a difference where the wetlands are, it's going to be very interesting to try to figure out how that should affect migratory populations such as shorebirds, where they're shifting them. Either they're going to have to go to different areas, in particular on the coast, that no longer are not there right now, that'll be changed by climate change, or there might be differences in how long they have to stay in an area to get the same resources. That's something that's going to be very hard to work on or figure out. So research directions, we think we need to look at macroinvertebrate abundance in relation to the benthic conditions and identify which populations are most at risk here, and relate these changing food resources to demands and predict which particular resource change might be the most of an effect on migratory birds. So that's kind of the direction we're heading for migratory birds and shoals. Now, for management considerations, and I hesitate to throw these out, but I guess in terms of idea generation, I think that disturbance on shoals is something that could be reduced in a highly urbanized estuary like San Francisco Bay. Consider protected areas to keep the areas that are good foraging areas through time more usable for birds. So that's something that we'll have to watch. If you don't know how climate change is going to change the resource, you should at least make the resource that you've got the best possible resource for the birds. Second, the bay edge areas are likely to become mudflats, and birds will start moving into those. I'm not sure there's anything you can do in management sense to improve that. But finally, one thing about restoration of ponds on the edge of the bay is that it could be that these ponds will help us in terms of maintaining some of the ponds are ones that won't be affected by sea level rise. So you might end up with those being good areas for keeping kind of safe havens for species like migratory birds. What about tidal marsh endemics? In endemic birds, the endemics are limited by habitat availability to a great extent. A lot of birds nest there and they need water levels that are just right. Sea level rise, in a lot of studies, has suggested will outpace sedimentation accretion in the marsh plain. So we kind of expect in at least some of the marshes, if not most of them, that we'll get areas that are not vegetated like they were in the past. So the habitat response in a lot of places is limited because we have levees, and it's likely predation will be a big problem with fewer refugia as we have these deeper water areas where there's no cover for endemic species to be able to disappear. So again, in the classic gradient elevation model for this, it means that we've got birds that are on the low slope now, it pushes uphill and everything then has to kind of slide up. But if there's a levee behind it, how do you slide up? So it makes it much more difficult for some of the species that are at the top end, where are they going to go? Like the black rail, for example, one that's found on the edge of the upland side. we've been doing a lot of work trying to map areas with elevation gradients that are very fine. And recent technology has improved enough that we can actually use kinematic GPS. We've also been using LiDAR, ground LiDAR, and getting accuracies of 1 to 2 centimeters. And I think that's the level you absolutely need to be able to follow these changes now to predict the changes that are to come. This is an example of tracking elevation change in San Pablo Bay Refuge in the North Bay here. And basically we had an old coverage that was existent that was really well done. And it allowed us to look at the differences between that coverage in 2008. And the interesting part about this is just in general that there actually is a gain in elevation as the North Bay has kind of had an accretion of sediment. And we expect though, of course, that may reverse with climate change as it continues and increases. So it's a way that we can follow particular properties and be able to get an estimate of the change.